5.2, simplifying exponents. If you need to look back at the rules of exponents that we covered in 5.1, you can just flip your notes packet back a page and look at those rules. They're all listed on the 5.1 notes. Okay, so we're going to apply those rules from 5.1. Okay, so here we've got two expressions in parentheses being multiplied, okay? And this first set of parentheses, is being raised to the 5th power. Okay, so when I'm looking at this, there's a lot going on here, lots of numbers and letters. So I need to be careful in my order of how I simplify this. So we need to take care of this exponent on the outside. This 5 needs to be distributed to all of the coefficients and variables here in the parenthesis. All of that is being raised to the 5th power because it's all inside the parentheses that the 5th power is on. So the 2 is raised to the 5th power. The a to the 5 is raised to the 5th power. And the b to the 3rd is raised to the 5th power. Okay, so I distributed that 5, that power of 5, to all 3 of these here. Okay, now I'm going to simplify that a little bit. We said in one of our rules in 5.1, we said when you raise a power to a power like this or like this, you multiply those exponents. Okay, now 2 to the 5th, what does 2 to the 5th actually mean? If you're raising something to the 5th power, what are you doing? What does any exponent mean? When you have an exponent or a power in the corner, the top right corner of the value there, who can tell me what an exponent is doing or what it means? It means you're multiplying whatever this base value is, in this case a 2. You're multiplying that 2 by itself 5 times. The power tells you how many times. Okay, so 2 to the 5th power means 2 times 2 times 2 times 2, 5 times. Means there's 5 2's all being multiplied. That's what that's telling us. So we need to calculate that. What is 2 times 2? And then times 2 again. So you said 2 times 2 is 4, and then what's 4 times 2? And then what's 8 times 2? And then what's 16 times 2? Comes out to 32. You can use a calculator, but your calculator, your 4-function calculator, is not going to have the exponent button. You actually have to type in 2 times 2 times 2 times 2 times 2, and that should come out to 32. Okay, now the exponent rule for the variable here, we've got a to the 5th to the 5th, a power to a power, that was our power property, says to multiply those exponents. So that becomes a to the 25th. You're doing 5 times 5 here. Okay, and then for the b, okay, that is also raised a power to a power. It's 3 times 5, which is 15. That would be your answer. 32, a to the 25th, b to the 15th. That means there are 25 a's all being multiplied, 15 b's all being multiplied. And remember, that's what that exponent tells you. All right, in number 2, we need to, I'm so sorry. I almost messed us up there. That's only the first part. We are not done here. That was just this first expression. There's still this 3ab squared out here. That's still there. That was being multiplied. I almost left it off, didn't I? Okay, so now we've got one more step to simplify this. Okay, so now we multiply the like base terms. So in this case, we've got a constant of 32 and 3. So we need to multiply 32 times 3, which is 96. So that comes out to 96. Okay, then I've got A's. I've got A to the 25th and A to the 2nd. When you are multiplying like bases, remember the rule, this is the product property, says that you add the exponents. So we're going to do A to the 25 plus 2. Okay, and then the B's, this B has no power, so it's an understood 1. There is no exponent, it's an understood 1. But that's going to be 15 plus 1 for the exponent on the B's. So that comes out to 96, A to the 27th, B to the 16th. So we combined a lot of properties there. We used, let me actually pull these up from yesterday for us, so I can reference them. So these properties here. So we used product property there at the end. We used power property when you have an exponent on an exponent. We used power of product, showing that the exponent outside the parenthesis goes to every term inside. So we used all three of these rules in that one problem. Okay. Number 2, we're going to use that product of power property again. This power of 3 that's outside needs to go to all of the terms inside. So it needs to go to the negative 2/3. It needs to go to the x to the 6th. And it needs to go to the y. Okay, so that goes to 1, 2, 3. It goes to all three pieces. So now I'm going to simplify. Again, negative 2/3 cubed means there's 3 of these. So if I were to multiply all of those out, because there's 3 of them, I've got a negative times a negative, which would become positive, times a negative again. So it's definitely going to come out negative. Okay, now when you're multiplying fractions, just multiply straight across the top. 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. So 8 in the top, and straight across the bottom, 3 times 3 is 9, times 3 again is 27. Okay, so I took this, I expanded it, this is called the expanded form, okay, and then I simplified it to this. Bless you. Okay, now here I'm going to use power property. We've got a power to a power, or an exponent on an exponent. So that is going to become x to the 18th, and then y cubed. So far, so good? All right, number 3. Again, we've got to distribute this outside power of 2 to the negative 3, the x squared, and the y. So -3 is squared, x squared is squared, and the y is squared. Now, squaring a -3, that means -3 times -3. What's a negative times a negative? A positive. So this is going to be positive, and then 3 times 3 is 9. So that comes out to 9. So our coefficient there came out to 9. And then we are using power property again here, 2 times 2. So that is x to the 4th, and then y squared. Okay, so some of these are a little quicker than others, and you'll start to get the hang of them and be able to move faster. Now here, this one uses the quotient property. We haven't seen this one yet. Okay, you've got like bases in the numerator and the denominator. So there's x's in both, y's in both, z's in both. So you need to remember that quotient property from yesterday says if you've got like bases being divided, you subtract the exponents. Okay, m minus n. So the numerator's exponent minus the denominator's exponent. So first I'm going to look at the numbers here and see if I can simplify that. So I've got 6 over, well, it's negative, and then 6 over 3. What is 6 divided by 3? Just 2, right? And this is negative. So that's just -2. So I don't have, oops, why won't my pen work anymore? What the heck? Oh, sometimes I have to close and reopen to get these to work right. So let me try that. All right, so that's -2 from the -6 divided by 3. Okay, now let's look at the variables. Okay, so I've got an x squared over an x to the 5th. So the rule says that would become x to the 2 minus 5. Okay, for the y's, I've got y to the 7th over y to the 9th. So that would become y to the 7 minus 9. And then for the z's, that's just a z. So if there is no exponent, what's the exponent understood to be? A 1. So if you need to write a 1 there, so that would be z to the 1 minus 6. So now I'm going to simplify those. I need y'all to stop talking, please. So -2, x to the -3, because 2 minus 5 is -3, y to the -2, and z to the -5. Now, I would actually take this a step further, but we haven't learned the negative exponent rule yet. We're going to talk about that in 5.3. So for now, that's as far as we can take it. But once we learn about negative exponent rules, we could take this one step further. Okay, but that's as far as we'll go for now. All right, here's another division one, but it's also got the exponent outside the parentheses. So we've got to distribute that power of 4 to everything inside here. Okay, but there could be some simplifying done before I do that. So I'm going to simplify inside first. Okay, so I'm going to do what we just did. I'm going to look at the x terms together. I'm going to look at the y terms together. And I'm going to look at the constants together and see if I can simplify this inside first. And then I'll distribute that power of 4. Okay, so on the inside, 25 divided by 5 is 5. And then that would be x, and then 4 minus 2. And then y to the 3 minus 7. So that is 5x squared y to the -4. Okay, now all of that is still outside these parentheses with that 4 hanging out there. That didn't go away. So now I'm going to take care of it. I'm going to take that 4 and I'm going to distribute it to the 5, the x, the y. So 5 to the 4th, x squared to the 4th, y to the negative 4 to the 4th. And then I'm going to use that power property again. 5 to the 4th means there are 4 5s being multiplied. Okay, and then I'm going to multiply these together and multiply these together. So that is x to the 8th, and that is y to the negative 16th. Now I just need to figure out what this 5 to the 4th is. 5 times 5 times 5 times 5 comes out to 625. All right, last but not least here, and we'll move on to 5.3. We've got this last rule out here. Anything to the 0 power. Why won't it let me highlight the 0? There it is. Anything to the 0 power. That was the special rule. Here, the 0 rule. Anything to the 0 power is 1. So I can just replace that whole outside term with a 1. Anything to that 0 power is 1. Okay, so I replaced all that with just a 1. All right, now over here, we've got this 2 on the outside of the parentheses that needs to be sent to all of those parts, to the coefficient, the x, and the y. So the 2 gets squared, the x cubed gets squared, and the y squared gets squared. And then that's all being multiplied by just that 1. Is multiplying by 1 going to actually do anything? No, 2 squared is 4. And 4 times 1 is still just 4. So essentially, I'm just going to drop that 1 on the end. Okay, now I need to multiply when I've got exponents on exponents. So that's x to the 6th, and that's y to the 4th. All right, so that's like combining all of those rules we had learned in 5.1 to simplify expressions with exponents. Okay, now we're going to, in 5.3, in a second, we're going to talk about the negative exponent rule. Okay, any questions right now? Okay, stop this recording, start 5.3.